Goodman's criteria or Goodman's theory. Okay, write down here. Goodman considered sigma ut as the failure criteria in case of pure static loading. Pure static loading and for completely reverse loading, endurance strength is considered as failure criteria. But in actual practice, these two ideal case does not occur or do not occur. Rather, the real loading is different from these ideal cases. Or failure occurs due to mixed condition. Failure occurs due to mixed condition. ना तो प्योर स्टैटिक ही होगा ना प्योर साइक्लिक रिवर्स होगा. एक्चुअल लोड कैन बी इन बिटवीन दीज टू आइडियल कंडीशंस. यस और नो. तो उसने डायग्राम बनाया. कैसे बनाया डायग्राम? ऑन एक्स एक्सिस, he considered pure static loading. So in case of pure static loading, when stress value will reach sigma ut, then failure will come in picture. So here he considered sigma m and here he considered sigma v. Okay. So for static loading, let's say this is the member and you are applying the stress like this. So load will increase 0 to, let's say, maximum value. So stress will increase minimum to maximum. Okay. So in this case, minimum will be equal to 0 and maximum will be equal to what? Sigma ut. So when sigma ut value will reach, material will fail. Material will fail. So on the sigma m, you will get a point of failure due to static loading, that will be sigma ut comma 0 comma 0. Now when you consider second case, load is completely reverse, plus and minus, plus and minus. Let's say plus 100 and minus 100. In that case, the mean stress will be 0. So sigma mean will be 0. This case will lie on y-axis. Static wala lying on x-axis. So point will be here. And failure will happen at the sigma E. So this point will be actually your sigma E. So 0 comma sigma E will be the point, because 0 will be for sigma m. So for completely reverse loading we know sigma m is 0. होता है कि नहीं? For completely reverse sigma m will be 0. Yes or no? So these are the two ideal points, but real situation lie between them. So you will connect with the line. Failure can occur here, failure can occur here, failure can occur here, failure can occur here, failure can occur here. Or if you talk about this point, then stress is less than sigma ut, failure will not happen. So at this point failure will not happen, not happen, not happen. These all are safe points. So here also failure will not happen, not happen, not happen. These are the safe points. So when you will go inside this area, for all these points, these will be your safe points. Okay. This line is your boundary line. Here failure will just about to start. When you will go at any point outside this area, failure will occur. Failure, failure, failure. Safe, 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 safe. Clear हुई बात? So he will connect the line like this. But there are always uncertainties regarding load, material and the dimension. So there is factor of safety. So we will not consider the sigma E maximum limit. We will consider maximum limit sigma E divided by Fs. Let's say Fs is 2, sigma E is 100. So only at 50 completely reverse loading failure will start. Here also you will consider sigma ut by Fs comma 0. This will be the point. Okay. So now let us assume this is AB and these are CD. So initially we were thinking we should live in this area, then we will save, because this is the boundary. After factor of safety, they are saying this is the boundary, but remain only in this area. So if you are living only in this room, then you will be more safe. So this will be the more safe zone. This is the safe zone and this is the more safe zone. Clear or not? Okay. So this will be the diagram or graph when you are applying the tensile loading. If you are applying the compressive loading, same line will go on left side. Same line will go on left side. Here it will be minus u c comma 0 minus UC divided by factor of safety comma 0. These will be the same point. Clear or not? बोलो। ये डायग्राम क्लियर हुआ? बना दो इसको। So this is for tensile loading. This is for compressive loading. Here it will be minus sigma UC divided by factor of safety like this. So this is the safe zone. Or you can say safest zone. Yes or no? इतना ही लिख दो बस, सेफ जोन सेफ जोन। ओके, बन गया। यहाँ पर लिखो few points. First point, point C and D are obtained. Point C इस तरह लिख दो, point D लिखो पहले, point D only perfect static loading और tensile loading. Point C only perfect completely reverse or cyclic loading. But these are ideal cases. So in actual practice, failure points will be lie on line CD, on line CD. That's it. Next, triangle OCD, safe zone without factor of safety. Triangle OAB, safe zone with factor of safety, okay. Now let us draw the derivation for it. Let's say this is the sigma V and sigma M line, and here this is the Goodman line. So when I am considering the factor of safety, AB line will be the failure line or the boundary line. Yes or no? बाउंड्री लाइन. एक काम करो, इसको ऐसे लिख दो, सी डी लिखा है, चलो सी डी लिखा रहने दो, नो प्रॉब्लम. सो एनी फेलियर पॉइंट पी विल लाई हेयर. इसका कोऑर्डिनेट क्या होगा? एक्स कॉमा वाई. एक्स एक्सिस, वाई एक्सिस. एक्स कोऑर्डिनेट, वाई कोऑर्डिनेट. सो हेयर this will be the values. This was your sigma ut, and this was the sigma ut divided by fs. This will be sigma m, because you are considering this point coordinate sigma m. So this value will be what? This value will become sigma ut by fs माइनस सिग्मा एम. बन जाएगा? बिल्कुल बन जाएगा. सो लेट अस कंसीडर दिस पॉइंट एज एफ पॉइंट. एफ पॉइंट. दिस विल बी इक्वल टू सिग्मा वी and this is equal to sigma E by Fs. And this will be equal to sigma E. Sigma E. Now compare the triangle OCD and FPB. Here you can write OC divided by OD will be equal to FP divided by FB. Yes or no? Bigger triangle, smaller triangle. Both are similar triangle. OC is sigma E, OD is sigma UT, FP is sigma V, and FB will become sigma UT divided by Fs minus sigma M. माइनस सिग्मा एम. ये वैल्यू बन जाएगा. क्लियर? सो हेयर यू कैन सॉल्व इट. इसको सॉल्व करो. ये आएगा, when you will solve, this much will become sigma E into sigma ut divided by Fs minus sigma m equals to sigma ut into sigma v. इसको मल्टीप्लाई कर दो सिग्मा ई सिग्मा यू टी डिवाइडेड बाई एफ एस माइनस सिग्मा ई सिग्मा एम इक्वल्स टू सिग्मा यू टी इंटू सिग्मा वी। सो ये यू टी वाला एक तरफ कर लो, इट विल बिकम सिग्मा यू टी, हमें एफ एस एक तरफ करना है, चलो कोई नहीं। सिग्मा यू टी इज कॉमन, सो इट विल बी सिग्मा वी माइनस सिग्मा ई बाई एफ एस इक्वल्स टू माइनस का सिग्मा ई बाई सिग्मा एम। कुछ गड़बड़ कर रहे हैं। वी बाई ई रहता है या ई बाई वी रहता है? वी बाई ई रहता है। एक काम करो, इसको हटाओ, पूरे में डिवाइड बाई सिग्मा ई कर दो। बन जाएगा। नाउ टेक दिस on different side. So when you will take on this side, sigma m will be equal to sigma ut common 1 by fs minus sigma v by sigma e, ऐसे आ जाएगा। So from here sigma m by sigma ut is equal to 1 by fs minus sigma v divided by sigma e. So 1 by fs will be equal to sigma m by sigma ut plus sigma v by sigma e. Yes, this is our equation or criteria. Okay, तो ये बन जाएगा। So this is called your Goodman's criteria. Goodman's criteria or Goodman's equation. Goodman's criteria or Goodman's equation. Here, sometime they will give you the value of factor of safety, sigma E you can find, and sometime they can give you the value of sigma E and sigma fs you can find. So this is the Goodman's criteria. सबको क्लियर हुआ? जय हिंद लिख दो फटाफट। Write down Jai Hind here if everyone clear up to this point.